exploring the world of radioactivity, benefits and risks. Radioactive rays are a type of radiation emitted by unstable atoms. These atoms have an unbalanced number of neutrons or protons in their nucleus, making them unstable, unable to release energy in the form of radiation. There are three types of radioactive rays. 1. Alpha rays. Alpha rays consist of particles that are made up of 2 protons and 2 neutrons, making their molecular weight equal to the helium nucleus. Alpha rays can be easily absorbed by matter and cannot penetrate human skin. Two. Beta rays. Beta rays consist of electrons or positrons that are released by unstable atomic nuclei. Beta rays have higher penetrating power than alpha rays and can penetrate human skin. 3. Gamma rays. Gamma rays are high-frequency electromagnetic radiation. Gamma rays have the highest penetrating power of the 3 types of radioactive rays and can penetrate human body tissue. Radioactive rays can be used in various applications, such as in medicine and industry, for example in material strength testing. However, excessive exposure to radioactive rays can cause damage to human tissue and even death, so their use must be avoided and regulated strictly. Radioactive rays are produced naturally by some radioactive elements, such as uranium and radium, and also through human activities such as nuclear power generation, nuclear weapons testing, and industrial processes that use radioactive materials. Exposure to radioactive rays can have various effects on human health, depending on the duration and intensity of exposure. Low levels of exposure over a long period of time can increase the risk of developing cancer, while high levels of exposure can cause acute radiation sickness, which can be fatal. To minimize the risks of exposure to radioactive rays, various safety measures are implemented in industries that use radioactive materials, such as protective clothing, radiation detectors, and radiation shields. In addition, regulations are put in place to ensure that these materials are handled and disposed of safely. Research is ongoing to find new ways to use radioactive rays in a safe and controlled manner. For example, in medicine, radioactive isotopes can be used for imaging and therapy, while in industry, they can be used for non-destructive testing and sterilization. Overall, while radioactive rays can pose a significant risk to human health, they also have useful applications in various fields. It is important to manage and control their use to minimize their potential risks, while maximizing their benefits. Efforts are being made to develop and implement safer and more environmentally friendly methods of using radioactive materials. For example, new technologies are being developed to reduce the amount of radioactive waste produced during nuclear power generation and to safely dispose of the waste that is produced. Another area of research is focused on developing materials that are less harmful when exposed to radioactive rays. For example, new types of concrete and other building materials are being developed that are more resistant to radiation and can be used in the construction of nuclear power plants and other facilities that handle radioactive materials. In conclusion, while the use of radioactive materials and exposure to radioactive rays can be dangerous, there are ways to minimize these risks through proper handling and disposal, safety measures, and ongoing research and development. However, it is important to remember that the use of radioactive materials and exposure to radioactive rays must be carefully controlled and regulated to minimize the risks to human health and the environment.